In this lesson, we're going to learn how to factor a difference or a sum of perfect cubes. So this looks similar to what we did with the difference of perfect squares, except instead of being two perfect squares, we're going to have two perfect cubes. For example, there's x cubed and 125. And you say, well, what do you mean a perfect cube? Well, x times x times x 3 times is a x cubed. Is there a number that multiplies by itself 3 times to give me 125? And there is. It's 5. 5 times 5 is 25, times 5 is 125. So this is two perfect cubes and a minus sign. Again, there are two terms, so when we're looking at difference, we're looking at factoring, which is what we want to do. We look how many terms is there. If there's two, it could be a difference of squares, which it is not. But it could be also a difference or sum of perfect cubes. Now, with cubes, remember with the difference of squares, it could not possibly have a plus sign here because then it would not be a difference of perfect squares question, and we'd say cannot be factored. But with squares, we can. So I'm just going to write down over here, it's kind of a, you can examine it for yourself, but if you have a difference of perfect cubes, like for example, if I had a cubed and b cubed subtracted, it will always factor, remember, it's not conjugates because it's longer than that. It's going to be a linear factor and a quadratic factor, and it always looks like this. The first factor is really easy. It's the cube root of the first one, the same sign as you have, and the cube root of the second one. Now once you have the first bracket filled in, then you can just ignore what you had before. You're going to fill in, this is going to be a quadratic, and I'm going to multiply a times something to be a cubed. It's going to be this one squared is your first term, this one squared is your last term, and this one times this one is your middle term. So a times b, which is always ab. Now, the signs will always be, this last one will always be positive, and this one here will always be opposite. So if this was a minus, this will be a plus. It's almost identical for the sum of perfect cubes. The linear factor will be a plus b, the two cube roots with the same sign. And the quadratic factor, I'll just cover that up, it'll just be a squared, b squared, a times b. The last one is always positive, and this sign will always be opposite, so it'll be minus. So these are our two, they're almost like little formulas to help us. So when I go to factor my question, I say, okay, it's two terms, it's not difference of squares, but it is difference of perfect cubes. So I'm going to say, well, it's this minus 1, so I know it's going to be a little bracket and a big bracket. And my linear factor is really easy to fill in. It's the cube root of that, x, and we said the cube root of 125 was 5, and the same sign, it's minus, so it's minus. So now I'm just going to cover that up because I don't really need that anymore. I'm just going to fill in here by taking this one and squaring it. And my last term will be this one squared. So you just ignore this up here now. We're just looking at this one squared, 25, 5 times 5, and then 5 times x, which is 5x. The last one is always positive, and the second one is always opposite. So that was minus, so this will be plus. And we're done. Okay, now let's try this one. Again, two terms. It's not a difference of perfect squares. It looks like it could be a cube. 1, it's a perfect square. It's also a perfect cube because 1 times 1 times 1. Okay, so that's fine. And then 8, 2 cubed is 8, so cube root of 8 is 2. And y cubed, okay, so we have a sum of perfect cubes, so we can use this formula over here. So it's going to put my equal sign, I'm going to put my small bracket and my bigger bracket. And in the small bracket, I take the cube root of that, so it'll be 2y. Right, the 8 and the y cubed. Cube root of 1 is 1, and the same sign as I have here, so it'll be a plus. And then I just ignore this one now. Just ignore it entirely. Just looking at this one, I'm going to take this first one, the 2y, and square it. Now you got to be careful. This is where mistakes are sometimes made. It's not 2y squared. It's the whole first term squared. So 2y all squared, which gives me 4y squared. That's where you have to be careful of. The last one will just be 1 squared, which is 1, and then 2y times 1, which is 2y. The last sign is always positive, and the second sign is always opposite, so it'll be minus. And you're done. Okay, so we have one more here on our list of things to factor. Now, I don't know if you remember from before, but I've always said we never like those negative signs in the front of our factoring. If there's a negative on your first term, you're going to want to change it. So you could factor out a negative here if you wanted to. Another option would be to change the order and put the positive one first. So I think I'll put the positive one first. Either one will work. I'll put the 27m cubed minus 64n cubed. That way, I no longer have a negative in the first term. We never want a negative in our first term when we're factoring. So now it's two terms, so it's either difference of squares or difference of cubes. I would also look for a common factor, but there's no common factors. It's not squares, it's cubes, definitely, because 27, the cube root of 27, if you use your calculator, will be 3, and that's a cube, and that's a cube, and the cube root of 64 is 4. So we're all set. It's difference of perfect cubes. I put a small bracket and a big bracket. The small bracket's easy, it's just the 2 cube roots. So that one will be 3m, same sign. This one we said was 4n. Okay, so the first bracket's always easy. Then just ignore that up there now. We're just looking at this to fill in this part. We just use this. We take this one and we square it. The whole thing, 3m squared. So that's going to be 9m squared. And then we're going to take this whole thing squared, which will be 16n squared. And then we're going to just take 4n times 3m, which will be 12. 4 times 3, mn. And now the last one is always positive, and the second one is always opposite, so it will also be positive. And we're done.